Assalamualaikum and hi everyone. I am Nurul Hafizah binti Azhar with metric number 192330 and currently a final year student of Bachelor Aerospace Engineering. Today, I would like to share about my final year project titled Numerical Analysis on Aerodynamic Performance of Coanda Wing Design. Here will be the outline for my presentation starting from the introduction, literature review, aim and objectives, methodology, results, and finish with conclusion. Before I proceed with my content, we need to know first what is Coanda effect. Coanda effect can be described as a phenomenon where the high velocity of fluid flow will have a tendency to adhere to the adjoining surface. The jet flow will remain attached to the surface and flow along it. This Coanda effect was discovered by Henry Marie Coanda back in the year 1930. How Coanda effect works is by having a jet flow blown on top of the Coanda surface where it will create a much lower pressure on the top surface compared to the free stream flow. This huge difference of pressure will generate high lift. This Coanda effect application has been widely implemented into various engineering applications, especially in UAV. The application of Coanda effect offers many advantages such as increasing the lift-to-drag ratio, improving the stall and install, and many more. The potential of Coanda effect has not yet fully utilized, and a lot of research and development need to be conducted in order to know the aerodynamic performance of the Coanda effect can be offered. However, having R&D is not an easy job. R&D requires sophisticated and large facilities, a lot of money, and take a lot of time just to get the results. Therefore, questions exist regarding a cheap way and faster way to analyze the aerodynamic performance of Coanda wing design, which is by obtaining a simplified technique in evaluating this aerodynamic performance of Coanda wing design aircraft. Moving on, here is the K chart that represents the breakdown of literature review part. Basically, on this K chart, you can see the yellow boxes are the flow that leads to the Coanda effect. Here, I want to highlight two findings on the Coanda effects. Paper by Berg has explained that the Coanda effect shows a significant change that can be seen in terms of lift and drag. The method of using Coanda flap has been investigated for so many years, but so far, Coanda flap has only been successfully applied to only certain aircraft in their normal operations like Blackburn and also Lockheed F-14. Other than that, paper by De La Montaña and Marshall investigated that Coanda effect is used in extreme short takeoff and landing stall vehicle to utilize the runway, airport ground, and the infrastructure that are already in existence at major airports but are too small for large aircraft, all while maintaining current air traffic pattern. The results show that the aerodynamic performance increased by using Coanda effect. Next, the aim of this project is to obtain a simplified technique in evaluating the aerodynamic performance of Coanda wing design aircraft. In this project, three objectives have been determined, which are first, to obtain the design requirement for Coanda wing design and conventional wing design. Second, to analyze the aerodynamic performance of Coanda wing design aircraft. And the third one is to compare the aerodynamic performance between Coanda wing design aircraft and conventional wing aircraft. In this thesis, as you can see on the right hand side of this slide, two different wing aircraft have been used, which are Coanda wing design and also conventional wing aircraft. In this case, it is Airbus A320-200 aircraft. Meanwhile, on the left hand side of this slide, you can see a flow chart of the methodology starting by obtaining all the design requirements for both aircraft and then proceed with the analysis of aerodynamic performance of Coanda wing design and finish with comparison of aerodynamic performance between Coanda wing design and A320-200 wing aircraft. Of course, before proceed with the results, validation needs to be done first in order to make sure that the method used is correct. In this thesis, lifting line theory has been chosen as a numerical method to evaluate the aerodynamic performance for Coanda wing design aircraft. Lifting line theory that was introduced by Prandtl is a mathematical model that predicts lift distribution over a 3D wing based on its geometry. LLT method has been applied and compared to the results obtained by the reference. Based on this graph, it can be seen that there are some difference between the LLT method and the reference. For the first case, the red color one, it has about 28.6% error, while for the second case, the purple color, it has about 6.6 error. Nevertheless, it is still valid that LLT method can be used to analyze simple data for Coanda wind design. This slide shows the outcome from the methodology. Here on the left hand side is the parameter used in the lifting line theory numerical method for both Coanda and Airbus A320-200. On the right hand side of this slide shows the difference between the Coanda wing design and the Airbus A320-200. As you can see in the Coanda wing, the wing is divided into three parts. The middle parts of this wing, which is the second part, is where the Coanda effect will take place. Here are some of the aerodynamic performance plots of the results. On the right hand side, you can see the plot between the lift coefficient at various angles of attack for both Coanda and Airbus A320-200. From the graph itself, Coanda wing design shows higher CL value than A320-200 by 18.7%, while on the left hand side, for the plot induced drag coefficient versus various angle of attack, the Coanda wing design has higher induced coefficient than Airbus A320-200 by 39.6%. By the end of this thesis, all of the objectives were achieved, where first, the design requirement for both Coanda wing design and A320-200 were determined from the literature reading. Second, the aerodynamic performance for the Coanda wing design aircraft has been analyzed from the lifting line theory method. And lastly, comparison of aerodynamic performance between the Coanda wing design aircraft and the A320-200 was made. In the comparison, the Coanda wing design has higher CL value than A320-200 by 18.7% for the plot of lift coefficient at various angle of attack, while for the plot induced drag coefficient at various angle of attack, Coanda is higher than A320-200 by 39.6%. That's all for me. Thank you for listening to the presentation, and thank you to everyone that involved in this project, especially my supervisor, Dr. Muhammad Faisal Abdul Hamid. Thank you.